Hi all, I'm Madam Kong. Welcome to my virtual class. The purpose of this video is to revise Organic Chemistry SK025 by using set PSPM 2016-2017. So this video is started with question 2. So this is the information given by the question. And then there are 4 sub-questions, 2, 1, 2, 2, 2, 3, 2, 4. Okay, let's start analyze the question. D is the isomer of an alkane with molecular formula C6H14 which possesses a quaternary carbon. So quaternary carbon is a very good hint for you to draw the structure. The reaction scheme that involves D is shown below. So it started from B. Okay, there's O. Then react with the concentrated H2SO4 and then form this one. So this is CnH2n is the general formula for alkene. Okay, after that, hydrogen is added with the catalyst, with the help of catalyst, and then form the alkane. So this is isomer alkane given by the question, and then have quaternary carbon. Undergo free radical substitution, okay, with UV, then sure form haloalkene. So based on here, right, you have to have a mindset. I know, oh, okay, this one is alcohol, and then undergo concentrated H2SO4. Is the formation of alkene, and then here is the electrophilic addition from alkane, and then free radical substitution from haloalkane. So first I have to grab the structure D first. Okay, because given the information is quaternary carbon, so sure this C will attach with 4 alkyl group. After I attach with 4 alkyl group, we check 1, 2, 3, 4, 5, 6, meaning that there are 3 methyl, another one is ethyl. So this is the structure D. Once I successfully draw the structure D, I can proceed for the next. Okay, dehydration of secondary alcohol B. So from here, the B is a secondary alcohol. You have to check from the D. How I can form secondary alcohol? Here primary. If C over here also primary, meaning that the OH is over here, secondary. So this is the structure B. Produce compound C. Okay, so compound C is an alkene. Suggest the structure of B and write the mechanism of this transformation. So now we look some revision. So if the question asks, okay, what is this reaction? This reaction is dehydration of alcohol. Okay, if the question asks what is the type of reaction? So this type of reaction is elimination. So as I said before, I encourage my students write down the name of the step. So step 1, protonation of alcohol. So this process is addition of H3O plus ion from acid to the hydroxide group, the OH group of alcohol. Okay, so must from high electron density. Okay, take the H, and then here bond breaking. So it will form the protonation of alcohol over here. Remember the plus for the oxygen atom, and then form H2O. Step 2, formation of carbocation ion by eliminate H2O. So the whole thing, the whole H2O for this part is eliminated. So and then form carbocation ion. And must be specific label. This is secondary carbocation ion. And then H2O is formed. Okay, step 3, formation of alkene. So in this case, the water, okay, the CH bond is broken. And then the hydrogen is eliminated from the secondary carbocation ion. So a new pi bond is formed between the CC atom to form alkene. So compound C is formed. Next, 2.2 suggest the structural formula for C and D. Since we know this is a structure for D, and then C we know the structure after we write out the mechanism, so should be no problem to give the structure C and D. And then E is the major product of the reaction of D with bromine in the presence of UV. So this is radical substitution reaction. So draw and classify the structure E. So actually there are, I can put over here, here, here. But if I put the bromine over here, both of them are primary haloalkane. So not stable. For here also primary haloalkane. Okay, that's why the answer is here. Secondary haloalkane. Okay, Okay, so you answer 2 questions, 2 marks. Okay, for question 2.4, suggest a chemical test to distinguish between C and D. Write the chemical equation and state your observation. Must write the equation and state the observation. So you must know C is an alkene and then D is an alkane. So we have to differentiate the C double bond C and the C single bond C. Before that, we already discussed the technique to answer this question. So start with, you have to give the name of the test, what is the condition and reagent of the test, equation 1, observation 1, equation 2, observation 2. Must state the reagent correctly. So what is the product if the test is given positive result? So it will form diol and then MnO2 brown precipitate. So purple color of KMnO4 is decolorized and brown precipitate form. Another one, you just write down no observable change. So this one you must state the solution of the color remain unchanged. So in this case, purple color of KMnO4 solution remain unchanged. Alternative answer is by using bromine in inert solvent. So condition must in dark. If not, both of them will given the same result. So this reaction at added bromine in inert solvent actually is electrophilic addition. 2 bromine is added. So the reddish brown color of bromine solution decolorized. So for alkane, no observable change. So the reddish brown color of bromine remain unchanged. Next, question 3. Question 3, there are 2 parts, 3A, 3B, and then there are 5 sub-questions for part 3. So let's analyze 3A. The reaction of 1-butanol F, and then the structural formula is given 1-butanol primary alcohol with several reagents is shown below. So first react with concentrated H2SO4. So this is preparation of alkene. H is a carbon-carbon double bond, and then this is oxidizing agent. So alcohol will become carboxylic acid, and then from G, how prepare OH. So how we can prepare OH? Okay, we can prepare OH from haloalkane. So that's why this is the answer for G. So draw the structure for GHI. So haloalkane can be bromine or can be chlorine, can be iodine as well. And then H is form alkane. So this is the major product. According to say Jeff rules, this is a minor product. I encourage you to write down this answer. Just write down the major product. And then this is form butanoic acid. 2. Suggest the reagent needed to prepare F from metana. So metana and then F is alcohol. Metana means that I need a green nut reagent. So if I need a green nut reagent, right, so there are 2 steps. Step is the green nut reagent. 2, you need to hydrolyze it. So this is the answer. I can use green nut reagent MgBr or green nut reagent MgCl. Yeah. Rename the functional group in compound H. Compound H is alkene, so C double bond C. So the functional group is carbon-carbon double bond. Question 4. Give 1 chemical test. Again, chemical test. To differentiate compound F from 2-methyl-2-butanol. So you check. Chemical compound F actually is a primary alcohol. 1-butanol primary alcohol. And then 2-methyl-2-butanol, when you draw the structure, you notice this is tertiary alcohol. So the best chemical test is Lucas test. What is the reagent? Concentrated hydrochloric acid, zinc chloride. So for primary alcohol, no observable change. Do not form cloudy solution after 10 minutes. But for this one, tertiary, right, it will form, okay, it will substituted, the OH substituted by Cl, and then the cloudy solution form immediately. Okay, next. Suggest the reagent to convert F to butana. If F is a primary alcohol, if I want to form butana, I have to use weak oxidizing agent. This is the only weak oxidizing millant, PCC in CH2Cl2. Okay, part B. State and show the mechanism for the reaction of 1-bromobutane with the hydroxide ion. So you check this 1-bromobutane actually is primary haloalkene. So primary haloalkene will undergo SN2. The full name of SN2 is bimolecular nucleophilic substitution, SN2 reaction. It's a one-step mechanism. So first, okay, the strong nucleophiles such as hydroxide attack the halogenated carbon. Okay, and then from the rear end, this called as backside attack. It's a slow step. So then a species with partially formed COH bond and partially broken CBr bond is formed. Broken. And then the configuration at carbon is inverted as the COH bond formed completely and the CBr negative ion leave. So there are few tips when you write down this mechanism. Make sure it's like an umbrella. Okay, so slanted to the left, slanted to the right, and then at the middle part you have to label transition state. And then for this transition state, you must label the negative, positive for this positive sign. And then here is the fast step. So check the tick that I assigned. So this is the point that you need to take note. And then for the yellow part, slanted to the left, for the red part, slanted to the right, and must in three-dimensional structure. Okay, next. So this is question 4. There are two parts, part A, 4 parts, part A, part B, part C, part D. And then for part B, there are 4 sub-questions. Okay, for this question, consider the following reaction scheme. So actually it started from K, is a symmetrical alkene. So once it's undergo ozonolysis, 2 products will be formed, and then these 2 products is the same because symmetrical. So propana is formed. Why? Because break and then from double bond O. So double bond OH is aldehyde. So 1, 2, 3, 3 carbon. So propana. So M is propana. From propana, okay, to L, undergo oxidation. So the oxidizing agent is KMnO4/H plus heat. Okay, from here, propana react with R and then form OH and then CN. So this is nucleophilic addition. So CN, so the reagent is KCN/H plus or NaCN/H plus. And then from N to N, this is condensation process. So for this condensation process, we always remember, need to eliminate H2O. So the H2 from the N compound and then the O from the carbonyl compound. So the C and N, okay, like this, we join together, C double bond N and H2. So condensation happens. Suggest the product formed when L react with, okay, L is carboxylic acid. So when react with SOCl2, the derivative of carboxylic acid, alkyl chloride is formed. If you remember, write down the byproduct SO2 plus HCl. And then lithium aluminum hydride followed by hydrolysis. So this is reduction. So from propanol acid become propanol. And when propanol acid react with sodium metal, so they will form, okay, C double bond O, O negative, and A plus. So the last one react with amine, so will form the derivative of carboxylic acid, amide. Okay, C, arrange K, L, and M in order of increasing boiling point, means 1 to 3. Explain. So M is aldehyde, K is alkene, L is COOH. So definitely carboxylic acid has the highest boiling point. And then alkene and aldehyde cannot form hydrogen bond. But this aldehyde is propana, and then alkene is hexene. So the molar mass of hexene is larger than propana. I know some of you may ask, okay, aldehyde suppose polar compound, alkene non-polar compound. So suppose polar compound which contain of dipole-dipole interaction forces, which is stronger than London dispersion forces. Yes, this statement is true if we compare between comparable molar mass compound. But for this case, aldehyde is just 3 carbon, propana, and then alkene is 6 carbon alkene. That's why K has higher boiling point compared to M due to the molar mass. So let's check the explanation. So L has the highest because can form hydrogen bond between the molecule, and the intermolecular hydrogen bond are stronger than van der Waals forces. Yes, because MK is van der Waals forces. K has higher boiling point than M because K has larger molecular size than M. Hence, the intermolecular van der Waals forces of K is stronger than M. Clear? Next, state the observation and write the chemical equation when M react with Tholen reagent M propana. So suggest one chemical test that can be constructed to confirm the presence of functional group in M, means carbonyl compound. So the observation is silver mirror precipitate is formed, and then by using equation propana react with Tholen reagent, and then the silver mirror precipitate form, and then this is the product as well. Another chemical test we can use Brady test, which will give the orange precipitate or yellow precipitate, and or Fehling test. Fehling test means it will form the brick red precipitate. Question 6. There are two parts, 6A, 6B. Let's check the question. State two types of bond cleavage that can occur in a covalent bond. So this is under Introduction to Organic Chemistry. Explain how this cleavage occur and identify the species form. Okay, so there are two. One is homolytic cleavage, another one is heterolytic cleavage. So you get one. Okay, then explain. So you are using the same molecule. Okay, you can use chlorine as well, form two free radicals, Cl dot Cl dot, and then you explain the bond. They are having the similar electronegativity. They can break symmetrically, and each bonding accept an electron, so a pair of free radical form. For heterolytic cleavage, you can use HCl. Okay, H is partially positive, Cl is partially negative. So the bonding atom have different electronegativity. So the bond between A and B break asymmetrically, and the more electronegative atom, so will take up the electron pair to form an ion, while the less electronegative atom lose electron pair to form the cation. So I already highlight the key point, you just check. Okay, next, complete the following reaction equation by showing the movement of electron using curved arrow. Discuss the bond cleavage involved in the reaction. So I have to complete the reaction. So this is the equation, this is the equation given. So the lone pair, okay, we'll donate to here and then form the dative bonds. So become NH4 plus and then Cl negative anion. So this is the curved arrow. Okay, so we have to discuss what happened. Actually, this one is heterolytic cleavage occur in this reaction. Chlorine is more electronegative than hydrogen, so the HCl bond break asymmetrically. Chlorine attract the bonding electron towards itself and then form a Cl negative chloride anion, and then hydrogen lose the electron to form a cation H plus. So ammonia NH3 is a nucleophile, so the lone pair of nitrogen attack H plus ion to form ammonium chloride. Ammonium ion. Okay, let's continue question 6b. Alkene are unsaturated hydrocarbon, so means carbon-carbon double bond, and chemically more reactive than alkane, carbon-carbon single bond. Treatment of an alkene Y with halogen acid HBr gives Z. So this is electrophilic addition from alkane. So Z is haloalkane. While hydrogenation of Y, so at 2 atom hydrogen will be added. So this is electrophilic addition as well, form AA. Reaction of Y with reagent BB give butanol and ethanol acid. So alkene which will give butanol and ethanol acid, this issue is oxidation, CmNO4/H plus heat as the product. Okay, now we need to explain the reactivity of Y. Okay, there is some different over here, so typing arrow, so we look at here, this is the original question. So just need reactivity of Y. So this answer, never mind, just revision. And determine the type of reaction involved. Yes, the type of reaction involved for each. And draw the structure of Y, Z, AA, and identify reagent BB, show the isomerism of Y. So let's check. What is alkene? So what is a reactive compound? Due to the presence of carbon double bond. So the type of reaction undergo is electrophilic addition. Z is haloalkane, is less reactive than Y but still undergo chemical reaction because the presence of the CX bond, which is a polar bond, undergo nucleophilic substitution reaction. So AA is alkane, unreactive because it is a saturated hydrocarbon, only undergo free radical substitution reaction with halogen in the presence of ultraviolet. So the function of ultraviolet is to provide energy in order to homolytic cleavage happen. Okay, by provide energy, so can form the free radical. So reagent BB is oxidizing agent, KMnO4/H plus, and then heat. And then alkene can exist as geometrical isomer because carbon-carbon double bond can form the cis isomer and also the trans isomer. Next, okay, we just transform all the explanation to equation. So this alkene react with HBr and then form, okay, bromine atom and hydrogen atom is added. So we need to follow Marconi curve rules. According to Marconi curve rules, in an electrophilic addition, the more positive means the H atom ion is added to the C, the carbon, double bond carbon that has greater number of hydrogen bonded to it. So H is added to here, Br is added to here. And then Y undergo hydrogenation. So hydrogen is added. And then Y, okay, we can either write the oxidizing agent like this or like this. If you want to write like this, right, okay, if you want to write like this, you must write out the 1 Roman, 2 Roman. So to produce after break, double bond O, so produce the 2 butanol, double bond O break, and then from double bond O, and then there is a hydrogen over here, that's why it become oxidized, become OH, so carboxylic acid is formed. So let's go for question 7. Question 7 also there are 2 parts, part 7a and part 7b. So 13 marks for 7a, 7 marks for 7b. Okay, let's discuss question 7a. Compound CC is formed from the reaction of benzene with methyl chloride. So this is, it will form methyl benzene. Future-Kraft calculation. Oxidation of CC methyl benzene with reagent DD. So oxidation, the oxidizing agent is KMnO4/H plus heat, produce EE. EE is benzoic acid. Coordination of CC. So this is the coordination of CC present of UV and then give FF. So this is a product of FF. Whereas reaction of FF with methoxide, so undergo nucleophilic substitution for the haloalkene part and then form GG. So while interpret the question, right, I will try to write all the equation first. Then easier for me to identify all the compound and reagent, all the product and reagent. So you can check the answer. And then the question continue with propose all the reaction involved in the initiation and termination step for the coordination of CC. So this is free radical substitution. Total there are 3 steps, but the question just one initiation step and propagation step. So okay, so initiation step, the molecule undergo homolytic cleavage when the sunlight is provided, because sunlight will provide the energy, okay, in order to make sure homolytic cleavage to happen and then form free radical. Then the termination step, there are 3 possibilities. So this is the equation 1, 2, 3. So let's check. And then don't forget there is another one question named the reaction. So this is Future-Kraft calculation and show the mechanism. Let's check. Okay, so the name of the reaction is Future-Kraft calculation, and the mechanism involves 3 steps. As I said before, right, when you write the mechanism, I encourage you to write down the name of the mechanism. So step 1 is formation of electrophile. Haloalkene is polarized by the catalyst aluminum chloride to form an electrophile. So next, step 2, formation of uranium ion. So the electrophile that form, right, will attack the pi electron of the benzene ring and the reaction intermediate. So uranium ion is formed. Step 3, deprotonation. So it will lose the proton and in order to retain the aromaticity of benzene ring. Okay, for 7b, 1-chloropropane react with Coercion in ethanol under reflux to form HH. So actually this is nucleophilic substitution. Okay, this statement I will convert into chemical equation. So plus Coercion, ethanol reflux, okay, and then HH is formed. Reduction of HH. HH reduced by using reducing agent. This you can using hydrogen with catalyst or 1 Roman lithium aluminium hydride 2H3O plus. So it will form CH2 and H2. Next, for hydrolysis of HH. So for this one, HH undergo hydrolysis using aqueous acid under reflux give KK. KK is benzoic acid. CN hydrolysis will form carboxylic acid. Okay, next, Grignard reagent of 1-chloropropane react with ethanol. So I have to show the Grignard reagent because here show the formation of the Grignard reagent. So this is the equation to show the formation of the Grignard reagent. Remember the solvent is dry ether. Okay, continue. Grignard reagent of 1-chloro react with ethanol. So this Grignard reagent react with ethanol to form LL. Okay, so this is ethanol, so it will form secondary alcohol. Okay, so continue, draw the structure for HHJJKKLL. Okay, since I transform all the sentences into equation already, I get all the product. Just rewrite what is HHJJKK and LL and write the chemical equation for the formation of JJ. So this is the equation of the formation of JJ. And then this is the equation for the formation of LL. At the same time, I already show the formation of this Grignard reagent. Okay, so I want to emphasize of the Grignard reagent. If you're able to direct get the product of LL, right, you just 1 Roman, 2 Roman. If you are unable, you try to understand this concept. Okay, you can, if you're confused, right, you just be calm and then identify, okay, for this C is partially negative compared to this one, for the MgCl is partially positive. And then the C double bond O, C over here is partially positive, and then double bond O is partially negative. I always say, right, the arrow is from the higher electron density move to the lower, so it will form the O negative MgCl. And then here this part, right, okay, the CH2, CH2, CH3 will bonded to this part. So this is the product formed before hydrolysis. Once it hydrolysis, right, this part will form OH. So this is LL. Clear? If you're not sure what is LL, by using 1 Roman, 2 Roman, straight away by using 1 Roman, 2 Roman, you can use this method. Do it step by step, as long as you understand the concept. Okay, next, question number 8. Question number 8, there are 3 parts. The first is about amine, second part is about amino acid, and then third part is about polymer. Let's check one by one. So for 8A, show how would you prepare aniline from benzene. So benzene is very unreactive, so there are only 4 electrophilic aromatic substitution for benzene. So the first one is nitration, so it will form the nitro, and then we reduce the nitro compound by using this reagent and then form aniline. So alternative reducing agent, we can use zinc, H+, SNH+, and so on. Check by yourself. Okay, next, aniline react with acidified sodium nitrate at 5 degrees Celsius to form MM. An addition of phenol to MM produce NN. So write the chemical equation involved and draw the structure of MM and NN. So while we write the equation, right, actually you will get the structure of MM and NN already, but you have to rewrite again. So the first one, it will form the aniline react with the acidified sodium nitrate at 0 to 5 degrees Celsius. Make sure you write the reagent correctly. And then benzene diazonium salt is formed. It is stable below 5 degrees Celsius. If more than that, it will form nitrogen gas. From this benzene diazonium salt, okay, react with phenol, it will form an azo compound. The name of this azo compound is 4-phenyl-diazenyl-phenol. So it is a dye in orange color. That's why next question will ask you, provide a significant physical feature. So the physical features is orange color, intense orange color. And a use of this compound NN. So the use of the compound is as dye. Okay, amino acid, isoleucine. Okay, this is the IUPAC name, is an essential amino. Draw the structure of isoleucine. Since the name is given, no problem for you to draw the structure. And also the structure at pH 2, acidic medium. So acidic medium, it will react with the base. That's why the NH2 will become NH3+. Next is 12, means basic medium. So the basic medium will react with carboxylic acid part, so we become COO negative. And PI means isoelectric point, react both, so NH3 CO negative. Simple question, huh? Then give the product form when isoleucine react with ethanol. So ethanol in the presence of hydrochloric acid as a catalyst, actually a bit like esterification. So ethanol will react with the carboxylate part to form the ester. At the same time, because there is acid, right, so the acid medium will react with the basic part, so become NH3+, or also can write like this. So, and then name this reaction esterification. Of question XC, A, difference between the term repeating unit and monomer. So you just give the definition. So what is monomer? Molecule from which the polymer is synthesis. And repeating unit is the actual structure that is being repeated in a polymer change. Next, give the repeating unit and monomer of polymer QQ. So this is polymer QQ. Okay, so this is addition polymerization. So the monomer, okay, sure there's a double bond because we form over here, this is the monomer. So when you form the polymer, it will form the single bond, means it break. So that's why you break over here. Okay, so when you break over here, this is the monomer. Here is another monomer. Okay, when it join together without the N, we call it as repeating unit. So actually the answer for the polymer and the repeating unit is the same, but the difference is without M and without this bracket. Okay, and then for the monomer, you remember addition polymerization should come from the compound that with double bond, carbon-carbon double bond. Okay, that's all for today. Thank you.